Hello everyone, welcome back. We have last talk of the day by Jes Ford on the model review, improving transparency, reproducibility, and knowledge sharing using MLflow. Over to you, Jes.
All right. Thanks everyone for being here. I know it's not like the first time somebody has said this, but I'm so excited to be here in person. So thanks for coming out to the last session of the day. I'll be talking about the model review with MLflow. To introduce myself, I'm Jes. I am a snowboarder first and foremost. That's the reason I'm currently living here in Salt Lake City. It's the reason I did my PhD up in Vancouver, Canada, and pretty much every other major life decision that I've made. I'm currently working as a machine learning engineer at Cash App, which is a part of Block, which you might know by the former name Square. My team works on natural language understanding applications in the customer support space. And today, I'm going to tell you why my team decided to adopt a process for a model review. I'll explain what that means and introduce the primary tool that we're using for review, which is MLflow. The bulk of this talk will be an intro to MLflow Tracking, and then I'll wrap up by explaining how MLflow is allowing us to solve some of these problems that I'm going to get into. All right, so when I joined Cash App about 1.5 years ago, our team had recently doubled in size, and we were increasingly deploying more and more models. But we didn't have any great record keeping on exactly what was in production, how those models had been trained, or just kind of generally what tricks or modeling approaches were working well in our space. So, what if a model needed to be retrained? A new team member joined and wanted to build off work that somebody else had done. And what was the precision supposed to be on that model before we deployed it? So the answer to questions like this would be like, let me see if I can find that notebook. And people are pretty good about keeping track of their notebooks that they had used and maybe checking them into GitHub. But as you can imagine, this is like not a robust or certainly foolproof way to be keeping track of this kind of stuff. So we decided that we needed to set some goals for like what a new process might look like for us. Number one, we wanted more transparency, some kind of record keeping of exactly what we were deploying. We wanted some reproducibility of past experiments that had been done, ease of building off of them by other people on the team or even the same person later on. And we wanted a format for knowledge sharing so we could actually learn from each other, get new people on the team up to speed much quicker. And on top of all of this, we didn't want to add like a bunch of manual work to all the other things we need to do. So we wanted to, whatever we were going to adopt, we wanted to be able to automate as much of this stuff as we could. So there's like a comparison here. I'm talking about a model review. There's obviously a thing called a code review. We review code to get more eyes on code, spot bugs, other issues before we deploy. Pull requests create like a nice record of commits to your software, and ideally also some documentation about decisions that you made or trade-offs that you considered in your design. And they give us this nice opportunity for learning from each other, right? When you're reviewing someone else's code or getting a review from someone else on your team, this is like a great opportunity to like learn from each other. So there's some parallels here. And there's some similarities between a code and a model review in that there's some code, right? You've written some training script or maybe a Jupyter notebook where you've defined some code that trains your model. But that's that's kind of where the similarities end, because for a machine learning model, there's a whole bunch of other context that's important beyond just like the Python code that you wrote that trains the thing. So, namely, what was the model performance? How well did it do on your test set? That's not obviously hard-coded in your training script. What data did you use, and what did you do to it? You might be able to get some of that from your training script, but there might be some additional context there. And then there's like this whole process thing, right? All the things you tried that didn't really work before you got to this final model that you like think is really great and you want to deploy. So, for all these reasons, we can't really review a model just by looking at the code. So it goes beyond just a code review. And so this led us to MLflow, which is an open source platform for managing the end-to-end machine learning lifecycle, is what it says in their docs. And MLflow has a few separate components under it. So there is the tracking, which is useful for keeping records of your machine learning experiments. There's the projects piece, which is a special way to format your code that makes it easy to reproduce runs. And there's a models piece. That's a special MLflow way to save your model that makes it easy to deploy in different deployment situations. There's also a fourth piece that's kind of newer. That's the model registry that lets you manage the model lifecycle. So MLflow was really nice because it's pretty language and library agnostic. It's not like tied to TensorFlow or any other specific machine learning library, and it's got APIs for different languages. I'll be using Python here, but it's pretty flexible for different use cases. And in this talk, I'm going to be focusing specifically on the MLflow tracking piece of MLflow. So tracking lets you easily log pretty much anything that you'd like to keep track of. So in the context of machine learning, this is probably your parameters, the metrics that you care about. You can track arbitrary things like plots or text files or Jupyter notebooks, which are all random files like that would be considered artifacts in MLflow. You might want to track the versions of code that you're running and the training data that you used. So you can pip install MLflow to get started, and I'm going to work through a few examples, starting super small. So here I'm going to import MLflow, and I'm going to log a parameter and a metric. So parameters and metrics are both key value pairs where the value is a numeric and the key is any arbitrary string. So you can name your parameters and metrics anything you like. And the first time I log something, what's called an MLflow run will be started automatically. And I'll show you examples in a moment of what that looks like. But you can think of a run as like a group of things that are logged together that makes sense as a group. And then I'm going to end my run to kind of end that group of things. A slightly more step up from that would be I'm going to, in this example, I'm going to start my run explicitly. So in the rest of the examples, I'll be using this context manager framework. So MLflow start run, I can actually give my run a nice useful name that I can refer to later. And then just like in the previous example, I'm going to log a parameter and a metric. And then I'm also going to log an artifact. So this will be, I'm just going to create and write to disk a silly little like one-line file here, and then I can log it using log artifact and giving it the path to my file. Okay, so I'm logging some things. Where do these go, and how is that useful? If you have MLflow installed, you can just run MLflow UI in your terminal, and this is going to spin up a little server for you. So we can go to that URL that's shown there in the output, and you would see something that looks like this. So this is the default MLflow experiments page. And what this gives you is a table of all of the MLflow runs that you have run. So at this point, we've got 2 rows in this table for the first thing we ran that we didn't explicitly name, and then this last run where we named it log artifacts. And you can see here there's the metrics and the parameters are kind of shown here at this high-level view. And we can click into one of these. So I'm going to click into this log artifacts example and go to the run page. So here we've got our log artifacts run, and there's some metadata up top. So we've got the date that this was ran, how long it took, a few other details. And then scrolling down, we have a section for all of the parameters and all of the metrics that I logged in this case. Down under artifacts, we've got our text file. And so I can actually click on that and see it rendered for me nicely in the browser, which can be kind of helpful. You'll also see here that MLflow is telling me the actual path location of this artifact. So when I ran this, I was working in this MLflow tutorial directory on my laptop in my home directory. And an ML runs folder was created there, which is where all of this stuff is being logged by default. So by default, if we don't do any fancy setup, we're just writing things to our local machine. And so this works well if you are working by yourself, you want to just get up and running quickly. But if you're wanting to share links to your runs with your teammates, or maybe to have everyone write to the same experiment, so you can compare different models, like in a leaderboard kind of thing, you'd want to set up probably a remote tracking server, and then everyone can be logging to that location, and there's different kinds of backend setups that you can make there. So these are just a couple of many different configurations that are shown on the MLflow docs page. So okay, so that's where we're writing to a place. How can we access that? I showed you already the MLflow Tracking UI, and that's what I'm going to use throughout examples in this talk, because it makes nice visuals and it's super handy. But you can also access all this data programmatically. So there's an API that lets you pull back results from your runs. All right, so nothing so far has been machine learning specific. You could use MLflow Tracking to log whatever you like. But I work on machine learning, so we're gonna do a machine learning example. So in the rest of these examples, I'll be using this data set called the 20 news group data set. It's one that you can get through sklearn. It's a whole bunch of text documents discussing different topics, and I'm just gonna use 2 of those topics, and we're gonna be building binary classifiers to distinguish between text that is about baseball versus hockey. In the interest of time, I'm not gonna go through the steps of loading that data up and transforming it, but I'll share links to this notebook if you're interested in how that's done. All right, so this example looks a little longer, but most of it is just standard scikit-learn stuff. So let me walk through what's important here. So like in the previous example, I'm starting my run with the context manager, and I'm going to name this hockey versus baseball, because that's what we're going to train a model to distinguish between. This top section, I am instantiating and fitting a simple logistic regression classifier. Then I'm going to get predictions for my train and my test set. And I'm going to make a plot. So I'm going to plot the precision recall, and I'm just going to save that as a PNG file. So all of that was just normal sklearn stuff. Now we're gonna track things. So here are all the MLflow commands that I ran. So I'm going to log the parameters that I passed to the model. I'm going to log metrics for the training and validation accuracy. And then I'm going to log that plot that I made, as well as this notebook itself that I'm running the code from. So those can both be done with log artifact. And then, of course, I probably want to track that trained model. So that's the final line here. So let's jump over to the MLflow UI and see what that looks like. So here's our run page for hockey versus baseball. I've got my parameters, I've got metrics, and then scrolling down, I have the Jupyter notebook that I ran this from. I've got my plot, which if I click on it, gets rendered for me in the browser, which is handy. And then I have the model. So there's a folder here. If I click into that folder, this is the standard structure that you would see for MLflow models. So I've got the model itself, which for scikit-learn is this model.pickle file. I've got a conda.yaml and a requirements.txt, and those can be used to recreate the actual environment that I trained this model in. And then there's this ML model file that's a special MLflow thing that specifies the types of flavors that this model is available in. So this model is available in the scikit-learn flavor, but all models in MLflow are also available as a Python flavor. And I'm not going to get too much into MLflow models in this talk, but I did kind of want to highlight this because the MLflow UI gives you this really handy little snippet here automatically that shows you how you could load up your model just from knowing the run ID and run inference using a built-in Python function in MLflow. So it gives you little snippets here of how you could run inference on a Spark or a Pandas data frame. So that's pretty cool, I think. All right, scrolling back up to the top of that run, I did want to give a quick shout out to this notes section. The notes section lets you write arbitrary markdown and then have that nicely rendered in the UI. So this is a great place to record any extra context, notes to yourself, things that weren't recorded automatically but are helpful. Yeah. Okay. So moving on to auto-logging. So in this last example with this machine learning model, we trained a model, and then we manually MLflow tracked each of the things we wanted. So we tracked the parameters, we tracked some metrics that we defined, we tracked a plot, but we had to add lines for all of that. MLflow has this kind of newer thing called auto-logging, which is super powerful. And basically, it allows you to use a single line of code to automatically track a whole bunch of useful stuff relevant to the model that you're training. So it's supported for all the types of libraries that I've used for modeling and a whole bunch more. So check out the docs if you don't see your favorite one here. But let's see what that looks like. So for another scikit-learn example, and going super minimal here, I'm going to import and train a random forest classifier. So here I'm just adding a single line of code, MLflow sklearn autolog, and then I fit the model, and that's it. So starting super basic, let's see what's available to us from that one line in the UI. So I didn't name this run. I get some kind of default run name up top, but take a look at all of the things that get recorded for me automatically. So first of all, this was a random forest model. I pretty much went with defaults. I set like the number of trees, but all of the things I could have set are being recorded for me. So if I went back and trained another model, I would still have the comparison here for all of the settings that existed. I also get a bunch of metrics for free, so out of the box. I didn't specify any, but I get accuracy, F1, precision recall, some others. And then, of course, I get my model, that's important. And I get some plots for free. So I get, in this case, a confusion matrix, a precision recall curve, and the ROC curve. So that all comes for free with that one line. Let's look at a second example. So this time, we'll do a TensorFlow Keras example. So it's going to look a little bit longer here, but the main takeaway is that we've really just got the context manager here to start our run, and then we just have this one line of auto-logging. I'm going to name my run sports neural net, and then I'll parameterize the name with a couple of parameters that I'm going to use in my model. So this is just, all the rest of this is a boilerplate TensorFlow. So I'm just defining a really simple, dense neural network with one hidden layer of arbitrary size. And then I set a few things that I need, like a loss and an optimizer metrics. I'm going to track accuracy and the area under the ROC curve. And then I just compile and fit my model for, I'll train it for 40 epochs. And so TensorFlow does its thing, it spits out all its training logs, and when it's done, we can jump back over to the MLflow Tracking UI and see what we get. So here is my sports neural net, 32 dimension, learning rate 0.1 model. And again, similar to sklearn, but different parameters here. All of the things I could have set on this TensorFlow model are getting recorded for me. And I get my area under the ROC curve and my accuracy, as well as the loss on the training and the validation data. Down under artifacts now, for a TensorFlow model, I'm going to get this model summary.txt. So if you've worked with TensorFlow, you've probably seen the model summary you can print as like a nice text description of your model. We get TensorBoard logs for free. That's pretty cool. And then we get the model. And so this looks a little bit more complicated because the TensorFlow saved model format involves more stuff than the scikit-learn example that I showed previously. But the basic structure here is the same. We've got the actual model. We have an ML model file specifying MLflow flavors. And then we have these files that are related to the environment that we're running in. All right, and you might have noticed that the metrics on these run pages look like links. and they are. So if I click on one of these links, I would be taken to a metrics page. So here I can select whatever metrics I like for the y-axis and plot them as a function of training step or of time, and I get these nice training curves. So this is like a TensorBoard style view that just kind of comes for free in the MLflow UI, and I think is super handy for the work that I do. Okay, so everything so far, we've been looking at one MLflow run at a time, which is cool, but things become really powerful and we want to compare different models. So let's see how we can do that. That last example I showed with the sports neural net, I trained a few different variations of that. So here in my table, I've got 6 different MLflow runs with different hidden dimension sizes and different learning rates. And this gives me like a leaderboard style view where I can sort. So if I care about accuracy, I could do a descending sort on this column, and I see like my top model on top. And maybe I want to compare, what was the difference between these top few models? I can check these boxes and hit the compare button. And this takes me to a view where I have a column for each of those 3 runs I'm comparing, and I can scroll through the parameters and the metrics. And MLflow really nicely just highlights for me when things are different, so I actually don't have to read super carefully to see what the difference was. And if I click into one of these metrics links here, I'll be taken to a view that looks similar to what I just showed. But now, instead of comparing multiple metrics for one model, I'm comparing one metric across several different models. So here I can see that the blue line, the model with the higher learning rate, converged a bit faster than the other models. All right, so that is the kind of end of the little intro to MLflow. And now I'm going to talk about how we're actually using MLflow in a model review process. So step 1 for us was to create and maintain some common training infrastructure. So some code that our whole team can use when we're training models that's flexible enough for different use cases and works for most of our problems. Once we have that, we can embed MLflow tracking throughout that. And this is important because we don't want to have to remember to add some MLflow tracking commands. We don't want to be thinking all the time about what's important to track. We want this to be taken care of automatically. And so that's what we do. This just lives in our code, and anytime we train a model, we just get all of this stuff recorded. So we track our training parameters, including a pointer to the data set that we're using. We track our metrics that our team cares about. Our environment. For us, that's our Docker image, the version of code that we're using, and the actual training script or the notebook that we're running from. And of course, we save our trained model, as well as a few artifacts that we need for deployment on our infrastructure. And then there are some kind of custom plots and analyses that we like to do on our team that help us understand maybe some caveats or things to think about with our model or just for debugging purposes as we're iterating. We use that notes section I mentioned for context. So it's great that we're tracking all these parameters and other things automatically, but there's always other stuff. There's always other things that you want to make a note of. And so in particular, we write up a little bit about what the business problem is that we're solving, maybe some notes about things that we tried that didn't work, and basically anything that you can think of that would be useful to you if you were to return to this model in a month or a year when you don't remember everything. Or for someone else on your team. So we follow those steps when we have a model that we like. And then before we deploy it, we require a model review. So for us, this looks like sharing a link to the MLflow run with everyone else on the team. We select a couple of reviewers from the team whose job it is to kind of read through that pretty carefully, look at the code that's associated with it, and then attend a 30-minute meeting to discuss, ask questions, maybe make suggestions, things like that. All right, so circling back to the goals that we had for model review, transparency. We're achieving this by having shareable links to basically all of the details of a model that we trained. Reproducibility is greatly improved because now we're recording everything that we need to actually recreate a training run or to build off a model that some other team member trained. Knowledge sharing. This happens both through this review process, but also just generally. It's super nice to be able to send a link to an MLflow run to your colleague just to kind of discuss things that you're working on. And MLflow is really helpful for this because it consolidates all these details about the model in one place. So in summary, MLflow is a really lightweight and powerful way to track machine learning experiments. If you're just getting started, autologging, just like a one-liner in your code, can get you a really, really long way. I only talked about MLflow Tracking, but you should also check out MLflow projects, models, and model registry, which are pretty cool. My team's using MLflow Tracking to automatically keep records of everything that we train and to review models before we deploy them. And this review process that I've described, this is a total work in process. This is evolving. If any of you have different or similar processes in place to achieve these kinds of goals, I would really love to talk to you. So please find me afterwards. I want to hear how other people are managing this kind of thing. Yeah, this presentation is a Jupyter notebook. It's on GitHub at that link. If you think that sounds fun, you want to use MLflow and train models and stuff like that, my team in particular is hiring for machine learning engineers. Cash App in general is hiring all across the place, growing pretty rapidly. It's a super fun place to work. I'd recommend you apply. And then I guess questions will be outside. But yeah, please come talk to me. And thanks for your time.